Thanks everyone for joining me today. My name is Partha Sitala. So containers, Kubernetes, these are the two words that are there everywhere today. Everybody seems to be doing it. Today my talk is going to be about how do you use containers and Kubernetes and run, deploy as well as manage complex applications like Hadoop. While the title says Hadoop here, I'm going to actually talk about not just Hadoop, but any complex data-centric application, whether it is big data, databases, NoSQL, AI, ML, and so on. So what are my credentials? Who am I, and what are my credentials to actually talk about this topic? I am, again, Partha Sitala, and I am the CTO of a company called Robin Systems. Prior to that, I was a distinguished engineer at Veritas Symantec. And I've had the good fortune of working across multiple products in the networking, storage, as well as application management space. Robin is it's a Kubernetes platform that brings big data, databases, AI, ML workloads to it. And we all know that Kubernetes has taken off big time, right? And there are a lot of stateless applications that are being deployed today. There's a significant amount of talk that's happening around how you can use stateful sets and things like that, and run databases and big data. Now, I'm going to talk about it from our perspective. When we looked at this problem, when we solved it, and some of the challenges that we faced when we are onboarding customers onto this platform, what is it that we actually faced? And that is going to be my talk, majority of the talk, followed by some demo clips that I can show of how the product looks. Now, we are not new to the space. We have been actually doing this for about 4 years. I'm just going to show you what we have been able to do for a wide variety of applications. So this is a very small sample set of our usage today. We have a very large company, an enterprise company, that has basically deployed a pretty decent-sized Elasticsearch Kafka pipeline, and they ingest about 11 billion events into that cluster every single day. We have another company that basically deploys a multitude of Cloudera clusters and Kafka clusters and Druid clusters onto one Robin platform. And we have about 6 petabytes of storage under management into that cluster, all running on containers. It's not just about the modern-day apps. It's also about when people talk about data-centric application, there's a huge footprint for traditional RDBMS today, Oracle RAC. So we have a customer who's actually deployed 400 instances of Oracle RAC clusters on Robin. So clearly, we have done one thing or two to actually enable these applications to run seamlessly inside containers and Kubernetes. That's going to be the majority of my talk today. So before we go into what can be done, how it can be done, I think it's very important to understand why you want to containerize, specifically these kind of applications. And there are two perspectives. There is a user-developer perspective, and there is an infrastructure CXO kind of a perspective. So let's look at that. So why would you want to containerize big data, database, and so on? So if you look at the developers, the developer basically says they hate filing tickets and waiting for their application clusters to be available. So one of our customers, they had a lead time of about 6 to 8 weeks to onboard a new Cloudera cluster with Kerberos enabled, SSL enabled, and things like that. And the reason for that is it takes a significant amount of time for folks to go set up hardware, install OS, configure it, patch it, then install Cloudera, configure it, and then give access to the end user. 6 to 8 weeks. Developers don't like that. Right? What's happening? People are essentially going to the cloud, and it's almost like it's creating a shadow IT problem for organizations. So developers want things like that, quick. The next is they like to experiment with tools. So think about a developer who basically says that, OK, I have a data analytic pipeline. I have an application that requires data store. He has a choice between using RDBMS, NoSQL, DocumentDB, what have you. But they do not know what is the right thing until they actually try it. So what they want is the flexibility to go experiment, but they don't want to deal with the complexity of configuring each application. You clearly do not want developers to first learn how do you set up Postgres, then figure out how to set up Mongo, then Cassandra. You don't want that, right? You want them to basically say, I want to experiment, fine. Let's figure out a way in which you can get you started very quickly. The third one is, this is a model that I think many of you might be familiar with. People want to develop and then deploy it, agnostic of where the infrastructure is, so almost like develop on laptop, push it to on-premises data centers, or the public cloud. And containers are a great platform for that because they offer deployment agility, and they basically make the deployment independent of the infrastructure, whether you're doing it within cloud or laptop or on-premises data center. That's the developer's perspective. Now, if you look at the other perspective, let me put a stat out there. As I have been talking to customers over the last few years, one of the things I keep hearing is many of these folks actually run their data-centric applications on bare metal, at least on-premises guys. And even in the cloud, this is a problem. And when they measure the utilization of their clusters, it's pretty low, about 40%. There was one instance where actually they were running a fairly decent-sized cluster with a 15% utilization. Now, what is the challenge? Obviously, you have to consolidate. There's nothing new here. But what is the challenge? Now, I was kind of reflecting back on my history when I was buying machines for my lab at my previous employer. And for 25 grand, I could actually buy a machine like this. Today, when I buy a machine for the same price point, this is what I get. What that means is with every hardware refresh, you actually make this problem worse. The utilization continues to go down. So that's one aspect of the IT challenge. There's another aspect. You are getting machines today that were not even possible a few years ago. So look at these. When you have fairly dense, you have one 4U box, which has 540 terabytes of storage in it. You have an AI, ML-based, GPU-based box on the other hand, which have, it's pretty expensive, right? It's about 141K. If you think about the NVIDIA DGX boxes, it costs 150K a pop. And you really want to keep that box busy. You really want to recover the money that you spent on it, which means that what do? You've got to consolidate. You really want to be able to load multiple applications, take them out when you're not using them, and so on. Now, obvious question here for the folks who have been in the industry for a long time. Hasn't virtualization actually solved this problem? Why do you even have to talk about this now? It has been solved almost 10 years ago. Actually, it's not. So a couple of reasons for that, and especially in the context of the applications that I'm targeting here. So the first is that data-centric applications, they want to run at bare metal performance. They do not want to have any hypervisor tags. That's one. Right? The second is that a single CPU cycle that you assign to a hypervisor, a single byte of memory that you assign to a hypervisor, is a byte of memory or a cycle of CPU that you have taken away from your application. Why would you want to do that? When you have a technology today that allows you to get the benefits of virtualization through isolation, but without any other performance penalty. So that's one. There's the other interesting aspect to this, which is majority of the software vendors are actually shifting towards shipping their software inside containers. Like even Microsoft is actually shipping SQL Server in containers now. Everyone is actually moving away from creating tarballs or RPMs into shipping things as containers, not as VMs. Now, you want to leverage that trend. You really want to be using containers because that's how your software is going to be delivered to you. And the side effect of that is that virtualization required a storage-level innovation where you had to go and deduplicate the commonalities across virtual machine images. Docker-based image management essentially takes that problem away from you. And so you are pretty much, whether you like it or not, it's a direction that the industry is taking, and that's what we need to do. Okay? So, okay, great. So you can use containers for these applications. What are the challenges? And here I'll speak about some of the challenges that we had to overcome to actually make many of these applications run inside containers and on Kubernetes. And there are two classes of challenges that we had to address. First is around general Docker and C groups management. The other one is around orchestration management. What are the challenges that you face? So if you look at C group space management, people think that, OK, C groups have been used, great. You just assign, put a max capacity of the number of cores or memory to a CPU or to a container, and you're great, you're good to go. In our journey, when you are actually containerizing Hortonworks, Cloudera, Oracle, DB2, SAP HANA, we actually ran into a bunch of problems, and we had to actually solve all those problems. So what are the challenges? And you can divide that into three camps, on the CPU, the compute side, the memory side, and the storage side. On the compute side, there are applications that require that the CPUs that you give inside a container, they follow a continuous or contiguous CPU ID space. Like Kudu, for example, has another quirk where it says that, OK, when I go and query my containers or my, let's say, /proc CPU info, what I see there assigned to me should also match a few other files that are there within the sysfs, procfs file system. You would not normally see this with stateless applications because they don't care. The more complex an application is, the more the application actually leverages the underlying NUMA awareness and all that. They actually go and query far beyond what Docker virtualizes on the C group side. Right? So that had to be solved. And without that, we pretty much had a big challenge actually bringing on SAP HANA on board and actually making it work. And other thing that we found out is it's not just about bringing up the container. When you bring up the container and you load it up with a lot of data, you're doing a lot of transactions, and you push it to the limit, then you'll see a bunch of other issues being exposed. For example, on the memory side, JVM runs inside containers. It's been running for a very long time now. But what we observed is that when you actually run a massive benchmark and push it to the limit, the container will get an OOM kill. And the reason for that is while you might cap the memory of a container that's running JVM, while you might cap the heap size using JVM, JVM itself actually can see more than what the container is offered. It's kind of strange, isn't it? But the reason for that is, in addition to looking at, again, proc meminfo and a few other files, it also makes a few other system calls that also need to be virtualized. And if you don't do this, and you'll actually not see this problem when you actually bring up a data node or whatever inside Hadoop, inside containers. You actually see this when you are stressing it to the point where it's exhausting memory, and then you'll see the strange OOM kills. So that had to be solved, and any serious JVM application requires that level of virtualization. Then you have the issues around huge page management, which is a big challenge for things like Oracle. That had to be solved. Common page cache across different containers. On the storage side, people say, OK, I can just attach bind-mounted volumes. It doesn't work like that for some applications. Oracle, MapR, they require raw devices. When you expose raw devices, you would expect that they'll just look at /proc partitions and they're good to go. It doesn't work. Once you stop the container, restart it, the WWN numbers have changed. So you're essentially breaking the correctness of the application. So you got to solve that. The next one is around IOPS management. C groups exist so that you can cap the consumption of applications, resource consumption of applications. It works more or less for some of the CPU memory things, but it actually is pretty poor for storage. The reason for that is the block IO based C group setting is on a per volume basis, which means that if your container, the app running inside the container requires multiple LUNs, multiple volumes, you really cannot control the amount of IOPS that all the LUNs across all the aggregate LUNs is going to be generating using the C groups base setting. So that's a challenge. You don't see that when you just bring up a container. You actually see that when you consolidate multiple such containers onto the same physical hardware, and you start noticing the noisy neighbor problem. So those are the challenges that we had seen, and we had to solve to onboard many of the applications on the container C group side. Now, on the Kubernetes side, a few other challenges. One is it's a very opinionated platform. It's a great platform, by the way. We love it at Robin, but it's a very opinionated platform. It expects that we are living in a microservices world, right? Now, what that means is your container can go down, and the expectation is that it can start up very quickly. It also expects that you would actually scale by adding more such containers, and you put a load balancer in front of it. Can you really do that with your data nodes? You don't do that, right? Because those applications themselves have a notion of topology, shards, partitions, key space distribution across those shards, and so on. Then they also recommend that you model your app in a microservices manner, where if you look at the pod construct of Kubernetes, right, you take a bunch of containers, put it in a pod, which essentially means that they're sharing the same namespace, but the expectation is that each container runs one unique service, one unique microservice. This is how the platform is designed. It's opinionated. But the problem is you're dealing with applications that have decades of assumptions built into them. And these applications, it's very hard to re-architect. And while even if some of the applications are being re-architected, for example, Cassandra has been re-architected to fit nicely inside a Kubernetes environment, the challenge is that older applications, harder to re-architect, and there is no real business driver to actually do that. There are other challenges. There are other fish to fry for them. So it's very hard for those applications to move. You cannot restart them quickly. You have to worry about storage and network persistence when things fail. And I will talk about this. It goes beyond what stateful sets offer. especially on the network side. The other thing is, it's an opinionated platform, that's good, but there is, again, decades of work around custom scripts that people have written with an assumption that you can SSH into the box and you can run stuff. You cannot go and tell somebody who has been running their clusters for like years and say, you know, you got to change your model. You got to actually do a Docker exec and bash. They don't like that. They won't have SSH access, which kind of breaks the model of running only one service within your containers. You might have to actually run supervisory, which is almost blasphemous to some of the people who are very religious about how the container image should be structured. But these are the real life challenges that you'll run into. Now, there was a very interesting survey that was recently done by CNCF, and they asked the responders, what are the biggest challenges that you see in Kubernetes? Storage was the biggest challenge. 48% of the responders said that storage management is very hard. 44% of the people said network management is very hard. Right? Storage and networking. But you know what's funny? This is the landscape. There are 27 storage vendors, 27 who are actually building storage just for Kubernetes. There are 21 network vendors that are building networking software for Kubernetes. So what's going on here, right? Despite all these vendors that are doing storage specifically for Kubernetes, networking specifically for Kubernetes, why is it that 48% feel it's a challenge, 44% feel it's a challenge? Because it's not just about creating persistent volumes or claims and attaching it. It is not just about persisting the host name when the stateful set fails over from one host to the other. And I'll talk about some of the challenges that you'll see as you go through and what we had to solve. So let's break it down into two parts. What are the operational challenges that you see, right, on the storage and networking side? So first is, as I said in the beginning, you want to consolidate these workloads. There is a business driver for that you want to consolidate. Now, when you consolidate, how do you ensure that you get performance predictability? How do you ensure that one user is not running a runaway query or a full table scan that's taking down the performance of someone else? Or some MapReduce job is basically tanking the performance of some other container that's running on the same host. On the storage side, how do you ensure that your I/O channels are appropriately set up so that you don't cause a noisy neighbor problem? The second is, many of these applications have constraints around how you do data locality. And that can be done because they have low latency requirements. That could be because they don't want to increase the throughput that is needed from their top-of-rack switches and things like that. So how do you ensure that you describe that, OK, this is my application. This application is built with the notion that it has data that is local. How does the orchestration platform essentially enforce that? That's one operational challenge. The next one is around affinity and anti-affinity rules. So one of the interesting things that we found, and I'll actually take two examples, one on the Hortonworks side, the other one is on the Oracle side. So in Hortonworks, one of our escalation that we got is the customer deployed it, and suddenly their name node is timing out. Why? Because it is sitting on the same storage node or same disk where Zookeeper was also putting its data. And when there was I/O contention, it pretty much timed out, and that resulted in cluster unavailability. Similar thing on the Oracle side, Oracle RAC has this thing called as a voting disk that's used basically for, think about it like a tiebreaker, if you will. Actually, it's not, but think about it that way. And it is very important that you get sustained, predictable performance to your voting disk. Otherwise, it will evict a node from the Oracle RAC cluster. So how do you ensure that you're anti-affinitizing not just the containers, but containers along with storage and network to ensure that you're not breaking the availability constraints of the application? On the networking side, this is a very big challenge with Kubernetes today. It's very common to see that you have consumers or applications that consume data services that might be running inside Kubernetes, but they're on a different L3 subnet. Now, in order to do that, the whole construct of how do you expose services, endpoints, put it through egress routes, and all that is very complicated for developers. It's very challenging. They just want L3 access to data services running inside their Kubernetes cluster, even if their apps are running elsewhere. So that's one challenge that you need to figure out. The other one is putting a load balancer, as I said earlier, in between your data-heavy applications will not work because these applications are not designed that way. As I said, you might have partitioning that is built into the protocol itself, and it knows how to route traffic and all that. You cannot just put a HA proxy or an F5 load balancer and expect it to work for many of these database-centric applications. And then 90% of the applications today, again, as I said, are 90% of the applications that are used in production today, your mission critical today, they expect that it's not just hostname, they expect the IP identity of your container or your application to be available in the event of a failure or migration. You got to solve these problems. If you don't solve these problems, you're really actually just doing some science project. You're just allowing applications to come up inside containers, but you really are not enabling them to be used in a production manner, in a mission critical manner. So it's basically, I mean, it comes down to, again, lack of, or rather loss of productivity, both on the developer side as well as the DevOps side, because they are just spending too much time doing storage and network management and things like that. So what's really happening is there's too much focus on the trees, right? You're missing the forest for the trees. So let's look at it from this perspective. Users, they interact with applications. Applications, or rather users consume applications, and applications consume infrastructure, right? So if you look at it from this perspective, the sole reason why infrastructure exists is to serve the needs of your application, and by extension, the requirements of the user. When you look at the forest, right, this is how we are solving it. You're looking at it from the wrong direction. You're looking at it from the infrastructure up into the app to the user. So where is our focus when you look at it that way? Your focus is on how do I do persistent volume claims? How do I do persistent volumes? How do I set up CNI? How do I do stateful sets? That is the dialogue we are having, right? That's one of the reasons why even with all these 27 different storage vendors, 21 different networking vendors, we are still stuck with basic database-centric deployment. What is it that we should actually be doing? Remember this flow. Users consume apps, apps consume infrastructure. What it means is we've got to look at the thing from the top. You've got to look at the forest. So you focus on the user-app interaction and have the app drive the infrastructure so that it meets the need of the users. So another way to look at this, by the way, the focus, as I was saying, is you should shift to apps from infrastructure management. So another way to pictorially look at this is, if this is your world today, and you're trying to bring up a complex application, you're putting all these pieces together, EVC, CNI, CSI, service, so many other things, and you expect to have a nice functioning car like that. What you're really getting is that, right? Now, it's great to do a science project, but if you really have to solve some real business problems, then you really have to focus on how do I move away from the car like that to the one on the top. You don't want to be spending time trying to figure out, oh, did my carburetor break, or did my whatever engine break and all that. You actually want to say, I want to go from point A to point B. Just get it done. I don't want to be dealing with all the underlying infrastructure challenges. So it's time to kind of reframe our thinking. So when you reframe our thinking, what we are saying is we are going to, as I said, we'll have application drive infrastructure to meet user requirements. And in this model, you would essentially have Kubernetes programmed for you, underlying stateful sets and all that. You're going to have storage programmed for you. You're going to have networking programmed for you. And that is what we have built. So I've been talking about what are the challenges we faced, what did we do to solve some of the technical challenges around C groups, orchestration, and all that. But I want to kind of elevate it and say, OK, if you were to solve it, what is the experience that the end user gets? Does the end user get the Tesla experience, or does they get the Jalopy experience? So in order to solve that, what we did is we combined 4 key ingredients. Now, we converged them. But in our convergence, it's not convergence in the sense of proximity. It's not about putting storage, network, compute, Kubernetes all on one host. That is proximity-based convergence. What we have done is we said, OK, because we are, by the way, we specialize in data-centric applications running on Kubernetes. So storage is a very key ingredient. Networking is a very key ingredient. So we built a storage stack that takes commodity disks, whether it's running on premises or it takes EBS volumes, Azure Block Devices, and all that in the public cloud. And it creates an application-aware storage fabric. Now, that storage fabric, why do I say it's application-aware? Because it understands the topology of the apps. And because it understands the topology of the apps, it can be programmed to do better SLA. It can be programmed to do better quality of service. And I'll actually show you what that means in subsequent slides. But when we talk about convergence of these 4 components, we essentially say that the components individually have been built so that they provide programmatic primitives that the top layers and the bottom layers can actually leverage to create this true application-defined world, where you stay at the application and then have the infrastructure drive itself. So when you do this, along with the workflow manager that I'll show you some demos, you'll actually see a different world. In that world, you move from doing this to actually having a dialogue based on user interaction with the application, such as this. How do I time travel across my different database states? How do I clone my database so that I can give a test.dog copy very quickly? How do I backup and restore? How do I migrate my application to a different cloud? I'm having it running in my on-premises data center today. I want to migrate it to a different public cloud. How do I do it not just with container migration, but actually with the data? So your conversation essentially changes from how do I take persistent volumes and make it consistently across on-premises as well as Google Cloud into something like this. So just to kind of dig a little deeper, what that means is your users, they expect a managed services experience. The first thing that I said, what do your users want? They don't want to file IT tickets. They say, I want to get, let's say they want to get a cloud Hortonworks cluster. They say, I want to get a Hortonworks cluster with storage, with networking, all the services enabled, Kerberos enabled, and SSL enabled, and a few other services. Right? So they should see a portal like this. They should click on, let's say, Hortonworks here. And again, we are not talking about toy deployments. You're talking about deployments where they'll have the flexibility of selecting the services that they want. So you should be able to go and enable the services that they want, whether you want Atlas or you want whether you want KD server to be enabled and things like that. For each other service, you would like to go and specify the scale at which you would like to deploy. You'd like to specify the compute needs. By the way, I just show CPU here. We also support GPU management in terms of how do you distribute and trade GPUs across different containers and so on. Then we do storage management. So you can basically say, OK, this is my data node. It requires 10 HDFS volumes. It might require 6 yarn local volumes and things like that. So you're saying, these are the services I want. This is the scale at which I'd like to do it. And these are the resources. But again, many of these applications, as I said, are fault domain aware. They are aware of rack-aware distribution and things like that. So it's very important to not just bring up the containers, but actually bring it up so that you don't break the fault domain constraints. It's important to basically say that, OK, your data nodes are spread across all these things and pass the rack labels back into yarn so that it knows, or name nodes, so that it knows that it has to distribute HDFS blocks appropriately. All right? So specifying data locality, anti-affinity, and all those things, you just go and toggle and say, this is what I want. Now, in this model, and you can, of course, save it as a template so that the next person who comes in can say, OK, I want to create a Hortonworks with, let's say, Atlas enabled, small or medium or large. Or let's say you go and provision. Now, just as an example, right? So this is a 64-node Hadoop cluster. Again, this is real live data from one of our customers. 64-node Hadoop cluster with all these services, about 1,400 cores, 4.5 terabytes of memory. Because we do storage, there's also 1.5 petabytes. It's in 23 minutes, you're up and running. It's not just container bring up. It is programming the underlying storage stack, networking stack, stateful sets, persistent volume claims, CNIs, everything. And you have your cluster up and running within seconds. And this is, again, as I said, the workflow should be consistent across any big data, NoSQL database, AI, ML, and a workload. That's what Robin provides. Now, you have it up and running. Common challenge. You have to go back to your ROI on your machines, right? Which means that as the priorities of your application changes, let's say there's a certain time of the day where you have to give more CPU, memory, I/O, or GPU resources to one application over the other, or you might have end of quarter results where you want to do that. So you want to basically give more juice and take it away from your application at runtime. What you want is something like this. So this is, again, a graph from one of our customers. So this customer was running, he took a big box, several big boxes, and they were running Kafka, 2 clusters of Hadoop and Druid. And they wanted, basically, they had this pattern where between 8 a.m. and 3 p.m., they have a real-time analytics cluster, where there's a lot of data that's being ingested. They wanted to give more juice to that by trading resources from another cluster on the same host. So you're essentially trading resources from adjacent application clusters and giving it to this and bringing it back. Now, Kubernetes has this concept of HPA, which is a horizontal pod autoscaler. Now, this is something that you would normally think about how you would do scaling, but that is service scaling. This is very different. This is actually not adding more data node components to your running Hadoop clusters, because that is a very destructive one-time operation. The moment you scale by adding more partitions, data gets redistributed, and as a result, there's a cost to that, right? And you cannot take it away also. So what is it that we have to do to solve this problem? This comes back to what I said earlier. It's not just about container management. Storage needs to understand application topology, its constraints, its policies, and things like that. So because our storage stack is application aware, what we have done is, in addition to virtualizing more appropriately the procfs, sysfs, and system calls, we tag every I/O with the application partition identity and things like that. And as a result, you can go and enforce minimum and maximum IOPS across an entire application, not just on a per volume basis. So it goes far beyond the BLK-IO-based CPU or cgroups management. So if you look at the far left there, my left, you're right, you see that Hadoop is one of the containers running on that host. It has about, whatever, 5 or 6 volumes. All of them are sending a lot of data. You want to go and throttle that unit, not individual ones. When you do this, you can essentially consolidate data-centric applications while guaranteeing that there's predictable performance. This requires, as I said, it's not just going and layering on top of some of the storage stack, but it requires you to have your storage stack understand application partitions, identities, and provide the essential programmable primitives that you can go and program to get this. The next one is, okay, I talked about very easy deployment. I talked about how you can consolidate while giving performance predictability. What are the other operational challenges? And this is where I would like all of us to kind of elevate our thinking from infrastructure components to applications. Let's say you have operational databases, right? Now, I'll talk about a few use cases, and then we can take it from there. So let's say I'm going to talk about, you have a Cassandra app. By the way, this is the Robin UI. You see that there is a Cassandra running. It has, 10 containers, 2 seeds, and 8 member nodes, and so on. Now, you might want to create a snapshot of your entire application. When you create a snapshot, so this is a workflow. So just click on that. You go to the top. You say, I want to create a snapshot, give it a name, put some retention policy, click it, and then you get a application consistent snapshot. What is an application consistent snapshot? Because Cassandra is a multi-partition application, when you take an app consistent snapshot, it has to create a consistent version, data-wise consistent version across all the partitions. So that's what you're going to get. But nowhere in this workflow did you have to go and program PVCs, PVs, network, none of that stuff. You're just saying, staying at the application, I want to snapshot this app, right? And you can preserve different snapshots IDs. What you also want to preserve is, as the application's topology changes over time, you want to preserve that as well. So you can actually use this to do time travel across different application states. So that is what you need. You need to elevate again to the application from infrastructure components, and let Kubernetes be programmed by the top layer workflows. Okay, now you have your snapshots. What else can you do? One common ask is, can I clone it? Of course you can, because we are app aware. So you can go and say, I have a catalog of snapshots that I've taken, and I want to clone it. But what does this clone actually mean? Does it mean that you're just cloning LUNs? I come from the storage industry. In the past, I worked at Veritas for a long time. Cloning has been done for almost 15, 20 years. There's nothing new to bring to the table here. Well, when people say, I want to clone my database, they don't want the storage admin to give them a bunch of clones from their snapshot. They want to basically click something, and they have an operational database that is cloned from a snapshot as of a certain point in time, which means that you need to have the same topology, the data should be shared, and the network identity should be changed, the cluster identity should be changed, so that you can get going quickly. I've been given a timer thing, so I'll go a little quick. The next one, of course, is backing up and restore. You want to do it at an application level, not individual LUN level backups. You say, I have my cluster, I want to back it up, boom, do it, done. Restore it to a previous point in time. Which again should be done very quickly from an application point of view. In the interest of time, I'm going to skip this part, but we have a booth, G3, and I welcome all of you to come join us, see the demos of these products, and see how we can actually change our experience of running big data, databases, AI, ML inside Kubernetes, when we stop looking at it from underlying infrastructure level components and start looking at it from an application level construct and say that application is the payload on which I'd like to perform these operations. Whether it is deployment, it is snapshotting, it is clones, it's upgrades, it's quality of service management, what have you. Right? Thank you.